Okay, so for number 11, we want to prove that these sets here, x, where x is an integer such that the absolute value is less than or equal to 3, and y, having these values, we want to show that they are equal. So for number 11, we're going to say, let x be the set of all x belonging to the integers such that the absolute value of x is less than or equal to 3, and y be the set of values containing -3, -2, -1, 0, 1, 2, 3. Okay, so once we have this, we're going to say let small x be an element of x. So for it to be in capital X, it needs to have this property here, right? So if it has that property, then we say, so the absolute value of x is going to be less than or equal to 3, which is equivalent to 2, and we're just going to use the definition for the absolute value of x. So x is going to be less than 3, but greater than -3, right? Because that's just the definition of the absolute value. And then we're going to say, note that the integers which satisfy this inequality are the integers -3, -2, -1, 0, 1, 2, 3. So x is going to contain these integers, right? And let me just copy this. So x is going to contain these integers. Okay, so if x contains all of these integers, we can say by inspection, we're going to say that all elements in x are in y and all elements in y are in x. By inspection, every element in x is in y, and every element in y is in x. So this means that x is contained in y and that y is contained in x. So we have shown a double inclusion, and whenever we have a double inclusion, thus this means that x is the same as y. So basically all we did here was we expanded the set x to show the elements that it includes, and then we just said, hey, by inspection, the elements in x are in y and vice versa, so we have a double inclusion and therefore they're equal. So that is it for item 11.